Hey class, today we're going to talk about prime factorization, okay? Right, okay, prime okay, prime factorization, okay? Also, this can also just be known as prime factor. Again, just this main part of the word, prime factor, okay? So it's prime factorization, but you also hear it as prime factor, okay? Before we talk about prime factorization, we actually got to know what a prime number is. And you have talked about this before in 5th grade, but we're going to go over it again here as well. Okay, so a prime number is a number greater than 1 that can only, and I mean like evenly, right? Evenly with no decimals or fractions or anything, only be divided by 1 and itself. Okay, with no remainders, right? No remainder or anything. So prime number is a number greater than 1 that can only be divided by 1 and itself. Okay, we can list a few examples here. Examples of prime numbers are, the number 1 is not prime, okay? Number 1 is not prime, it has to be greater than 1, not 1 though. Can't be 1. 2 is a prime number. 3 is a prime number. 4 is not prime. 5 is a prime number. 6 is not prime. 7 is a prime number. We'll do the first couple examples. 8 is not. 9 is not. 10 is not. 11 is a prime number. 13 is a prime number, and so on. There's more prime numbers, right? There's a whole lot more, okay? So these are some examples of prime numbers, okay? These are some examples of prime numbers. So we just want to have that down. Okay, now, the opposite of a prime number, or the counterexample, is composite numbers. And so composite numbers, right? Composite numbers are the opposite of this, right? Composite numbers, these are numbers, these numbers have multiple or many of, right? These numbers have multiple, I guess you can say divisors. Right, multiple divisors. It can be, there's multiple ways that you can divide these types of numbers. Again, examples of these are 4, right, divisible by 2, 200. I'm just naming a bunch of random ones, right? 36 can be divided by 9, 4, 2, 18. These types of things. There's a whole bunch of them, composite numbers as well. So yeah, so just again, those are some examples of composite numbers as well. Okay, and one of the ways I like to talk about these as well is because what we're going to be doing here when we're prime factoring, when we're doing this up here, we're essentially having numbers and we're going to break them apart by their multiples, by numbers that multiply to get them, right? So prime numbers, one way I like to also describe prime numbers is prime numbers are numbers that cannot be broken down. And you'll see what I mean by that shortly. I'll put that in clouds. Okay? Prime numbers cannot be broken down. Okay? And composite numbers can be broken down. okay, can be broken down. Okay, and so this is some of the ideas. Prime numbers cannot be broken down. A prime number is a number greater than 1 that can only be divided by 1 in itself. Some examples have been given. Go ahead and draw a line right here. Okay, and then composite numbers, I underline prime. Composite numbers these numbers have multiple divisors, numbers that can divide them evenly, right? Like 4 can be divided by 2 and 4 and 1, and 200 can be divided by a whole bunch of numbers, 100, 50, 2, with the number 2, right? 36 can be divided by 4, can be divided by 9, 18, 2, just a bunch of divisors, okay? So just, that's the idea, okay? All right, go ahead and erase these. All right, so one thing I do want you to remember is that factorization is a fancy word for factor. Okay, keep that in mind. Factorization is a fancy word for factor. Okay, prime factor. Again, that's a simple way of doing it. Okay. Now, factors, right? Factors, what I want you to think of these as, okay, when we factor a number, we're essentially breaking it apart into its multiples. Okay, so you can think of these as, just think of these as pieces to a multiplication puzzle. Okay, think of this as pieces to a multiplication puzzle. So what we're going to do is whenever we prime factor or prime factorize, we're trying to find the pieces to a composite number. We're trying to find the pieces to it that multiply to get it. And we're going to get more into detail when we get to an example. So here we go. Here's our first example. Okay, prime factor 50, the number 50, okay? Prime factor the number 50. Let me scoot this over just a second, a little bit. Okay, so over here on this side, we're going to prime factor 50. So we're going to use something called a factor tree. Okay, we're going to use a factor tree. Okay, what it is just a tree, kind of a diagram of a tree, and we're going to break it up into its factors. That's why they call it a factor tree. So what we're going to do is we're going to use these little, kind of a upside down open triangle thing, right? We're going to use this idea. We're going to find two factors, two numbers that multiply to get this 50, okay? Two numbers that multiply to get this 50. And I like to always, my thing is if we have an even number, then we're going to start with the number 2. We're going to start with the number 2, right? Because it's even, we can cut it in half, right? And so what's half of 50? 25, right? So we're going to put 25 here. Now, once we're done with the 50, right? Figuring out two factors of 50. 2 is a prime number. We talked about it a minute ago. I'm a point over here, but we wrote it down a minute ago, right? 2 is a prime number. So again, we stop here. We can even circle it at that point if we want to. 25 prime. Can we think of two numbers that multiply to get 25? Besides 1 in itself? Can we think of other numbers? Well, it's 5 times 5, right? 5 times 5. Is 5 prime? Can we break 5 down anymore? Can we think of any other factors or any multiples of 5? No, right? So both of those, right, are prime factors. So now, what we're going to do is we're going to grab these numbers that we circled. I'm going to go ahead and put it up here. And I'm going to say 2 times, remember we use the dot now for multiplication, right? Times this 5 times this 5, right? And so we end up with these multiples as our answer. Now let's go ahead and do this. 2 times 5, 10. 10 times 5, 50. So this is actually equal to 50, okay? And so we've talked about exponents, right? So what we have here, this one right here, the 50 is what we call standard form. Standard form. That's the standard way that we write numbers, right? We call this expanded form. And then now, since we talked about multiplication, remember, we talked about exponent, right, which is repeated multiplication. This right here, I'm going to write it down here. 2 times 5 to the 5th power. We have 2 5s that are being multiplied. Remember, exponents are repeated multiplication, right? Exponents are repeated multiplication. So what we're going to do is the 2 is by itself because there's only one of the 2's, right? One of the 2's. And how many 5s do we have? We have 2 5s. So that means 5 is our base. 2 is our exponent, right? And so we rewrite this in what we call exponent form. Okay, so we have standard form, expanded form, and exponent form. Okay, we're going to go over more examples in the next video. Thanks for watching, guys.